Because you already developed a strong understanding of cantilever beams and you know exactly how to calculate the support reaction for the load cases that we introduced to you, let's talk about another load case that we have not formalized yet. It doesn't need much of our attention, but it needs to be addressed so that we are all on the same page. And what I want to talk to you about is called concentrated moments. You have already seen those in your homework. At least you had like 2 problems that gave you a glimpse into that. But again, we have not defined those properly. So let's talk about that real quick. So let's say you have a rigid structure that actually is under the action of rotation. What do I mean by that? So let's say I have a support reaction here and a support reaction right here. And I'm now welding something to that structure somewhere in a random place. So let's say right here, I weld something to the top and to the bottom, and that is rigidly connected now. It is one part. This is very rigid. This is all one part of the structure. And I will now apply a force to it in one direction and then a force in the other direction. So for example, let's say I apply a force here and here. And what you can see is that this type of force is actually called a force couple because they are parallel to each other and they have the same magnitude. So let's call this here F1 and then this is F1 as well. The 1 stands for the fact that they have the same magnitude. And they actually also equally distanced from the structure. So let's say here we have 0.5 meters and 0.5 meters. It doesn't really matter as long as it's equal. And what these forces do is they, of course, cause a rotation at this point, right? So we identify them with a moment. We can symbolize them as M. And so in this case, it would actually be F1 multiplied by 1 meter. And that is something I want you to think about because you may think, how is this possible? How can this force couple be replaced by this force times 1 meter? And that is because this force has half a meter and this force has half a meter of a lever arm. And you can also rotate them about this point. It doesn't really matter. Then you have this force times this entire lever arm, which then would be 1 meter. But F1 times half a meter plus F1 times half a meter is F1 times 1 meter. And so what engineers do is they replace these type of force systems by an acting moment. But you can think of these moments every time you see them as something that causes rotation. So think about you actually putting your finger on here, like out of the plane. Remember, this is in the XY plane. And now in the Z plane, you actually put your finger there. And now you rotate your finger on that structure. So you actually make it rotate this way around. So what would happen? You would probably push on this support and you would lift this support up. And that is the concept you need to understand, right? So you're rotating down on this side and you're rotating up on this side. And of course, these come in many different forms. So you can think of them not as down and up, but you have to understand when they push down and when they push up. So for example, you can also have a second moment, let's say this one here. So this here could be, let's say M2, and then that M2 is acting right here. And that does exactly the opposite. This one pushes actually down here and pulls up here. And again, if you don't see that yet, what you can do is you can take the piece of paper, put a needle here, and then rotate it in this direction. And you will see that this will go down and this will go up, right? And so therefore, this support reaction has to balance that, and this support reaction has to balance it by pulling it down. So please understand that these can cause clockwise or counterclockwise rotations, right? So for example, here for M2, we have a counterclockwise rotation, whereas for the other one, we have a clockwise rotation. And they, of course, result in different support reactions. But the support reactions are not all affected by them. In fact, let's look at the unit, right? So for example, M2 could be given with, let's say, 10 kilonewton meter. And so the kilonewton meter is a unit that only works in the moment equation, and you should not let any other equation be affected by this. So you may ask yourself, why is this? Because this obviously has an effect on the support reaction, but it only has an effect because of the rotation, the kilonewton per meter. And you can look at the blue description here and you can say, but there's forces that actually produce this, and you would be right. But notice one important thing about this force couple here. The force couple is actually in equilibrium in the x direction, right? F1 minus F1. So they are actually in equilibrium. The only thing that they do is they cause rotation. And so the moment only affects the moment equation. So concentrated moments only affect the moment equations. And by that, I'm talking about the rotational equilibrium. Which we usually describe as the sum of the moments about any point P being equal to 0. That is what we need to affect it. They do not impact force equilibrium. All right, and that is all we actually need to know or learn about concentrated moments. The rest we learn through application when we actually look at the following example. So what we need to know about concentrated moments conceptually is given here, and the rest we will now study through application. Let's go ahead and solve the problem.